When you use an estimator to perform logistic regression, why do you not need to specify your training labels representing categorical values in one hot notation? In this lecture, we'll see how we can implement logistic regression with estimators. Once you've done linear regression, though, logistic regression is very, very easy. There's really just a little bit of tweaking that you need to do to get this working. The code for this implementation is in a Python notebook named Logistic Regression with Estimators. The code cells at the very beginning will have all the helper methods and the baseline implementation for logistic regression. Setting up the feature specification for logistic regression is identical to how we did it in linear regression. Set up a real valued column. And the main crucial difference in logistic regression is the estimator that we use. Logistic regression is a way of classifying our input data into categorical values. That's why we use a linear classifier. We do need to set up our training data set and its associated labels in a way that the estimator wants it to be. We've seen this code before though. We use the np.expanddims command in order to set up our returns data in the form of a two-dimensional array. The returns for our S&P 500 should be an array of arrays. We want to ignore the column for intercept from our x data, which is why we select just column 0. Use np.expanddims on our y data as well to get a two-dimensional array of our training labels. Our training labels in this case can just be true false values. It need not be in the one hot notation. That's because the logistic regression estimator will take care of converting this to the one hot notation. Once again, saving you a lot of detail work. The input function used by this regressor is exactly the same as before. We use the numpy input function so that we specify our feed dictionaries in the form of numpy arrays. It takes in the x feature vector, the y labels. We can specify the batch size as well as the number of epochs that we want the training to run. You can now train this logistic regression model by calling estimator.fit. This takes in the input function that you just set up and redundantly the number of steps or epochs you want to run this training for. In case you happen to be tweaking your model parameters, you can set up a different input function as well. The input function one shot sets up another numpy input function where the batch size includes your entire training data set and the number of epochs for your training is exactly 1. You can call estimator.fit in order to run your regression model on any of these input functions. I've just chosen this input function at random. Try it with the input function one shot and see how the result changes. If you remember our logistic regression implementation from earlier, we had to jump through a lot of hoops to calculate the percentage accuracy that our model generated. We used np.argmax, did a whole bunch of comparisons, and so on. Using estimators, though, all of this is abstracted away from you. You can simply call the fit.evaluate function, specify the input function that you want to evaluate, and store the results in results. I was playing around with this code for a little bit. At this point, I'm choosing to evaluate the input function one shot. But once again, the choice of input function is up to you. You can run estimator.fit with one input function, get a reference to the fit object, and call fit.evaluate, specify the input function, and it'll tell you how good your training process was. Print out both the results and the variables. The variables will print out the bias value and the weight of our regression parameters. Notice within the result that the accuracy of your logistic regression is printed out for you. Here the accuracy is 0.6959, 69%. At this point, you know that estimators abstract away a lot of the details of our regression models from us. An estimator can accept your training labels in raw form. We just pass in a bunch of true false values in the form of a two-dimensional array. Under the hood, it'll convert it to one hot notation and run the regression training.